Welcome to Pastor Victor's Academy. Embark on a journey through the world of engineering mathematics and electrical engineering with our educational tutorials designed specifically for engineering students. Whether you're mastering calculus, solving complex circuit problems, or exploring power systems, Pastor Victor's Academy is your ultimate learning companion. Join us as we break down complex concepts into clear, easy-to-understand lessons, helping you build the foundational knowledge and skills needed to excel in engineering mathematics and electrical engineering courses. Subscribe now to kickstart your learning journey and gain the confidence to tackle engineering challenges head-on. Let's unlock the world of mathematics and electrical engineering together, one lesson at a time.
Welcome to Pastor Victor's Academy. It's nice having you here again. Maybe this is your first time watching my video. I would encourage you to check my previous videos and I can assure you that you'll not regret watching them. So in this lesson, I'll be talking about the gradient of a curve at a point. I will also be giving a brief introduction to differentiation. I beg you to pay attention as we continue with the lesson. The first thing I want to define is a curve. A curve is a continuous path traced by a moving point. Now, take for instance, we have this, we have this, we have this. All these things are curves. So, what are the characteristics of a curve? The first one is that a curve has no jumps or gaps. So, you can see that we don't have a gap. It was a gap. Something like this is a gap, no matter how little, as long as there is a jump or gap, it's no longer a curve because it's not a continuous path. Secondly, a curve is one-dimensional. That means that it has length, but not width or thickness. Saying that it has no width or thickness means that the width is insignificant compared to the length. Of course, you could call here the width. But when you compare the width to the length, you see that it is insignificant. So we assume that it has no width or thickness. So in that case, a curve is one-dimensional. But when something is two-dimensional, that means the width is significant. In other words, we should have an area. And when it has a height, it means that the height is significant. So we should have a volume. So when we're dealing with one-dimensional shapes, we ignore the width, we ignore the height, we ignore the thickness, whatever you call it, and we'll focus on the length because other dimensions of that particular shape are insignificant. So here we are ignoring everything except the length. Our focus is on the length. Then a curve may be straight or curved. In this case, we have a straight line, whereas in this case, we have a curved path. Then it can be open or closed. Like in the case of a circle, this is a curve, this is a curve, this is a curve. So it can be open or closed. It may have sharp points or angles. Take for instance something like this. Here is a sharp point. Why is it called a sharp point? Because when we get to this point, the slope just becomes positive. Initially it was negative. Here it just becomes positive. Not progressively, but an instantaneous change in the slope. So that's why it's called a sharp point, a corner, an angle. Okay, the next thing we'll talk about is the gradient of a straight line. The word gradient refers to the rate of change or slope of a quantity. That means the rate at which something is changing with respect to changes in another quantity. So that's what gradient is also called slope. Hence, the gradient of a straight line is the slope of the line or the rate of the vertical change to the horizontal change between any 2 points on the line. So note that the gradient of a line is the same between any 2 points. The expression for the gradient or slope is given as change in y over change in x. That's for a straight line. Now, change in y over change in x is the same thing as y2 minus y1 over x2 minus x1. So this is a straight line. Then we have x0 as the first point, x1 as the second point, x2 as the third point. So these are the corresponding points on the y-axis. For x0 to have y0, for x1 to have y1, for x2 to have y2. So how do we calculate the slope of this line? We say the slope of the line is given as change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. Take note, I used y2. That means I subtracted y1 from y2. Take note, if I pick y2 as the guy subtracting, definitely I'll pick x2 as the guy also subtracting. But assuming I picked y1, that means I'll be having y1 minus y2 over x1 minus x2. So both expressions will give you the same answer. Because this one will give a negative value, this one will give a negative value. Negative will cancel the negative, which still gives you the slope. So I have y2 minus y1 over x2 minus x1 as the slope of this line. Then we say that expression is also the same as saying y1 minus y0 over x1 minus x0. So anywhere you pick 2 points on this line and you take the difference of y divided by the difference of x, it will still give you the same thing. That's why we say the slope of a straight line is constant, irrespective of the points you pick. Now let's take an example. Here we have the equation of a straight line, y equal to 2x plus 1. So we are meant to get the slope of this line. How do we calculate the slope of the line? We pick points for x randomly. So let's say when x is equal to 1. So we'll be having that y is equal to 2 into 1 plus 1. Y equal to 2 plus 1. That gives us 3. When x is equal to 2, we'll be having y equal to 2 into 2 plus 1. Then we'll be having that y is equal to 4 plus 1. That gives us 5. When x is equal to 3, we'll be having that y is equal to 2 into 3 plus 1. And that gives us y equal to 6 plus 1 is equal to 7. So we already have 3 points and we can plot our graph with the 3 points. Since it's a straight line graph, we just connect the 3 dots using a straight line. We're having, so let's plot the graph. At x equal to 1, y is equal to 3. So here is our x axis, here is our y axis. At x equal to 1, y is equal to 3. So have this point. Then at x equal to 2, y is equal to 5. Here is x equal to 2. And we look for y equal to 5. Then at x equal to 3, y is equal to 7. We look for y equal to 7 at x equal to 3. And this is the point. So you can see that we're having a straight line. Connecting the points, we'll be having this. That's what our graph looks like. So this wouldn't have been necessary for getting the slope of the graph, but we just wanted to show that with the 3 points, we can plot the graph in a straight line. Now, to get the slope, what do we do? Let's call this guy y0, call this guy y1, call this guy y2. So say slope or gradient, whichever one, is changing y over changing x, which is equal to y2 minus y1 over x2 minus x1. So what's our y2? Our y2 is 7. Our y1 is 5. Then what's our x2? Our x2 is 3. And our x1 is 2. So that gives us 2 over 1, which is equal to 2. That means change in y over change in x is equal to 2. Now let's use the other points, that is x1, x0, and y1, y0. So here's our y1. We have y1 is equal to 5. And we have y0 is equal to 3. And we have x1 is equal to 2. And 1, x naught is equal to 1. 5 minus 3, 2. 2 minus 1, 1. That still gives us 2 as the slope. Now, notice that when x is equal to 0, y is 1. You can confirm. Put 0 here. You'll be having 2 times 0, 0. That means y is equal to 1. And when y is 0, x is minus 0.5. Put 0 here. Make x the subject. You'll be having 1 crossing over, becoming minus 1. Divide minus 1 by 2. You have minus 0.5. If you use those points, you still get the same value for the slope of this line. Now, I want to derive the equation for a straight line using this expression for the slope of a straight line. We say the slope, let's call it m, is equal to change in y over change in x, which is equal to y1 minus y0 over x1 minus x0. Now, if we make y1 the subject, we'll be having y1 minus y0 is equal to m into x1 minus x0. So y1 is equal to m into x1 minus x0 plus y0. Now let's say x0 is equal to 0. Then when x0 is equal to 0, y0 is equal to c. Because we cannot just say that y0 is 0. It's not always the case. It just depends on the equation of the line. So let's say that at x0 is equal to 0, y0 is equal to c. So we'll be having that y1 is equal to mx1 plus c. So we can remove the subscript 1 and just write y is equal to mx plus c. Remember that m here is our slope and c here is this guy 1. So you can see that when you have the equation of a straight line, the coefficient of x in that equation is your slope, where the constant is your intercept. That means the value of y when x is equal to 0. So if you check the graph we plotted before, that's the graph of y equal to 2x plus 1. You'll notice that the graph cuts the y-axis where y is equal to 1. And at that same point, x is equal to 0. So I want to talk about positive slope and negative slope. Now, when is a slope positive? The slope of a line is positive when the line is like this. That means inclined like this. So it's as if somebody is climbing a hill. So when we have a line like this, then you should expect a positive slope. But when we have a line like this, as if you are descending a hill, that this guy is descending a hill, then the slope will be a negative slope. So you can try it. You can write the equation of a line, then give it a negative slope, plot the graph. You will notice that the line has this inclination. But if you give it a positive slope, you'll notice that the line will have this kind of inclination. So when we have something like this, it's a positive slope. When we have something like this, it's a negative slope. This one is ascending, this one is descending. So let's take some examples as we continue. Now, for the first example, we'll have find the gradient of the lines joining the following pairs of points. We have 9,7, 2,5, then B, 3,4, and 8,5. Now, how do we go about finding the gradients for the lines? We say S, Y. That means the first point is for the x-axis, while the second point is for the y-axis. So we can say that x0 is equal to 9 and y0 is equal to 7. Then x1 is equal to 2 and y1 is equal to 5. So change in y over change in x is equal to 5 minus 7 over 2 minus 9. That is y1 minus y0 over x1 minus x0. So that gives us minus 2 over minus 7, which gives us 2 over 7. If we do it the other way, that means subtracting these values from this. We'll be having 7 minus 5 over 9 minus 2, and that gives us 2 over 7. So either way gives you the slope of the graph. Okay, for the b part, we can say x naught is equal to 3 and y naught is equal to 4. X1 is equal to 8 and y1 is equal to 5. So change in y, change in x is equal to 5 minus 4 over 8 minus 3. And that gives us 1 over 5. So the slope is 5. You can do it the other way. You get the same answer. That's to say 4 minus 5 over 3 minus 8. It gives you minus 1 over minus 1, which is still 1 over 5. So let's solve the second example. It says determine the gradient and intercept of the following equations. For the first equation, we have y equal to 3x minus 2. Now, how do we determine the gradient or the slope? We just compare with the equation for a straight line. Already we know that y is equal to mx plus c. M is the slope and c is the intercept. So what do? We compare. Y is equal to mx plus c and y is equal to 3x minus 2. So in that case, the slope of this graph, that's change in y over change in x, which is equal to m, is equal to 3. And the intercept c is equal to minus 2. Okay, for the b part, this is also the equation for a straight line. The only difference is that it has not been arranged like to look like the equation for a straight line. So what do? We make it look like the equation for a straight line. Then by comparing, we can get our slope and intercept. So we say 2y is equal to minus 4x minus 1. So y will be minus 4x over 2 minus 1 over 2. Y will be minus 2x minus 1 over 2. So when we compare, m is equal to minus 2 and c is equal to minus 1 over 2. So when we plot the graph, we'll be having the slope as minus 2 and the intercept, that is where the graph cuts the y-axis, as minus 1 over 2. That leads us to the next thing, the gradient of a curve at a point. Now, I want you to note that a curve that is bent has no specific slope. What I mean is, we can't say 2 is the slope of the curve because it keeps changing along that curve. So it's not constant, unlike that of the straight line. We have a picture here. Here is a hill. I believe some of us have climbed a hill before. So here is a hill. This is a guy climbing the hill. Now the guy begins his journey here. Assuming that this guy here, you will notice that it's as if you are falling backwards. That's to show that the slope is what? Positive, depending on how steep it is. Then, as the guy is ascending, it comes to this point. You can see that the slope here is not the same here. So this one is less positive, but this one is more positive. Then getting to here, the guy is like somebody standing on a plane surface. So it is not steep, it's just flat. That's a flat surface rather. So there we say that the slope is equal to 0. So slope was initially positive. Now the slope is 0. Then the guy finds himself again at a point where the slope is positive. That is as if he's ascending a hill again and falling backwards. Then he keeps moving until he gets to a point where the surface is also flat again. There's no slope there. So it's neither falling backwards or falling forward. So in that case, the slope is equal to 0. But on getting here, he begins to feel like somebody that's about to fall forward. That's a kind of responding to the force of gravity. There we say the slope is what? Negative. Why? It's like somebody descending a hill. So throughout the journey, we don't have a specific value for the slope. Slope that was once positive became 0, then became positive, became 0 again, and became negative. So once we have a bent curve, we don't have a constant value for the slope. It keeps changing along that curve. So before we go ahead, I want us to define the word tangent. That's T-A-N-G-E-N-T. Now, what's a tangent? It is a straight line that touches a curve at exactly one point without crossing it at that point. So this definition is very, very critical. A straight line that touches a curve at exactly one point without crossing it at that point. So it's just like two surfaces coming in contact but without intersecting. So take for instance, you have this curve. Now I want to touch this point, but I don't have to cross the point. That means I will draw a line that just hits this point but doesn't cross it, doesn't intersect. So we'll be having a line moving like this. So you can see that I was able to hit the point without having to cross it. So that's what a tangent is. If we apply the definition to a straight line, then we'll be having a line parallel to that straight line, and we'll be getting the slope of the line. But when we apply it to a bent curve, it will not be parallel to the bent curve because it's bent. It's not a straight line. So it will only touch the curve at that point without having to cross that point. Now, assuming we have a circle, here's the center, here's the radius, this is also the radius. Now, if we are drawing a tangent to this point, you'll notice that this will be at 90 degrees to the radius. So, meaning that the tangent to a circle is always perpendicular to the radius drawn to the point of contact. So, here's our point of contact, this is the radius, and this is the tangent. Both are always perpendicular, in other words, at 90 degrees to each other. So that takes us to the gradient of a curve at a point. What is it? It is the slope of the tangent to the curve at that point. So when we draw a tangent to the curve at that point we're interested in, then we take the slope of that tangent. That gives us the gradient of the curve at that particular point. So you can see that it's something practically difficult, but we can get an approximate value of the slope using this method. Now I want us to try an example as we go ahead. Okay, here we have an equation y is equal to 2x squared plus 1. And we want to find the gradient of the curve at 0.5 and minus 0.25. So what do? We begin to plot. We have our x, we have our y. We have minus 0.75, minus 0.5, minus 0.25, 0, 0.25, 0.5, and 0.75. So I will pick this range of values for x, that's from minus 0.75 to 0.75, is so that we can capture this value 0.5 and minus 0.25. So at minus 0.75, if you use your calculator, you'll be getting 2.125. Then here you get 1. Here you get 1.125. At 0, you have 1. Then at 0.25, you have this. You have this and you have this. So when we plot the graph, what are we going to get? We are going to get a curve like this. So if you use your graph plotter, put this equation there and plot the graph, you'll be having a curve like this. You notice that this side is a mirror image of this side, where the intercept is at 1. That's the minimum value for the graph. So here we have 0.25, 0.5, 0.75, and 1. So we are using an increment of 0.25 for x-axis, and the same thing applies to the y-axis. For the y-axis, I didn't start from 0. Take note. I started from 0.5. So here will be 0.75. Then here will be 1. Here will be 1.25, 1.5, 1.75, 2, 2.25, and 2.5. So how do we go about finding the gradient of the curve at the required points? That's 0.5 and minus 0.25. For the x-axis, you can see that this point is our 0.5. So it corresponds to our 0.5. What do? We draw a tangent to this curve at that point. So here's my tangent, this straight line that touches this point but doesn't cross it. So here's my y1 and here's my y0. Here's my x1 and here's my x0. So y1 is approximately equal to 1.94. This is a graph I plotted on the board, so you don't expect it to be very accurate. So what do we have? Check this 1.75 and these two. So between this and this, we have our y1 here, and this is approximately 1.94 from my own estimation. You can plot your graph and find out what yours is. Then for my y0, it corresponds to 1.25. So here's my 1.25. Then for x1, what do we have? 0.69. This is 0.75. This is 0.5. So from my estimation, it's approximately 0.69. Yx0 is approximately 0.38. This is 0.25. This is 0.5. So from my estimation, it should be 0.38. So when you do y1 minus y0 over x1 minus x0, you'll be getting approximately 2.23. You can plot your own graph. You may not get 2.23, but you should get a value that is very close to 2. Now, for the next guy, minus 0.25. This is my minus 0.25, which corresponds to this point. I drew a line tangent to that point. Then, here's my y1, and here's my y0, and here's my x1, and here's my x0. My y1 from my estimation is equal to 0.75. Then my y0 from my estimation is equal to 1.28. This is 1.25. And this is my y0. So approximately 1.28. Then my x1 is 0. That's the origin. My x1 is 0. Then my x0 is approximately minus 0.44. This is minus 0.5. So it's very close to minus 0.5. So that's approximately minus 0.44. Calculate your change in y and calculate your change in x. Divide change in y by change in x. You'll be getting approximately minus 1.2. So these are the gradients of the curve at 0.5 and minus 0.25. Please take note of the answers because we still use this equation for the next thing we want to discuss. Before we conclude this lesson, I want to talk about differentiation. Just a brief introduction to differentiation. So what's differentiation about? It is the process of finding the derivative of a function. So when we're trying to find the derivative of a function, what we're actually doing is called differentiation. So what's the derivative of a function? The derivative of a function is the function of the independent variable. In this case, our independent variable has been x. So that gives the value of the slope at any point on the curve. So what it means is that the slope of a curve can sometimes be the function of the independent variable. So when we are getting that function, we call it differentiation, and that function itself is called a derivative. Now, look at the expression we have on the board. F prime of x is equal to dy dx. This is called prime. It's not to the power 1. So what it means is that we can either express the derivative this way or this way. So either we use f prime x or we use the y dx. And it is given as the limit of change in y over change in x. So this is the slope. This is called slope as change in x approaches 0. So if you don't know what limit is all about, you can check my video on limits. Then you can get to understand what limit is all about. Now, here we have a graph. On this axis, we have the y. Then we have the x-axis here. We have a curve. Then we have a point P on the curve. We have another point Q on the curve. Then I connected both points using a straight line. Here I have x1 for point Q and it corresponds to y1. X0 for point P and it corresponds to y0. You notice that the slope of this line is equal to change in y over change in x. Assuming we are to find the slope of this line, that's what we'll be doing. We'll just take the difference in y values, take the difference in x values, we divide, and that gives us the slope of that straight line. Now, we define change in y as y1 minus y0 and change in x as x1 minus x0, where the slope of point P is dy dx. So this point P and the slope is dy dx. So we're interested in getting the gradient at that point. So what happens to the slope of this line? Assuming this point Q begins to move downward until it gets to P, you notice that x1 will be approaching x0, then y1 will also be approaching y0. If x1 is approaching x0, it means that change in y is approaching 0, and change in x is also approaching what? 0. So if both changes are approaching 0, that's change in y approaching 0, change in x approaching 0, definitely the slope of the line, which is change in y over change in x, will be approaching dy dx, which is the slope of the tangent at the point P. Hence, dy dx is equal to the limit of change in y over change in x as change in x approaches 0. So the function we get when we take this limit is the derivative of the curve, and it will give us the slope of the curve at any point on the curve. So let's try it using the previous equation. The previous equation we had y equal to 2x squared plus 1. Now remember that change in y is y1 minus y0, and change in x is equal to x1 minus x0. That implies that x1 is equal to x0 plus change in x. Now, using this equation, we'll be having that y0 is equal to 2x0 squared plus 1. Then y1 is equal to 2x1 squared plus 1. But the question is, what is x1? x1 is x0 plus change in x. So y1 is equal to 2 into x0 plus change in x squared plus 1. So this gives us 2 into x0 plus change in x into x0 plus change in x plus 1. So y1 is equal to 2 into x0 times x0, x0 squared, x0 times change in x, x0 change in x, then x0 times change in x, x0 change in x. When we add the 2, we'll be having 2x0 change in x. Then change in x times change in x as plus change in x squared, then plus 1. So y1 is equal to 2x0 squared plus 4x0 change in x plus 2 into change in x squared plus 1. Now remember that we are looking for change in y over change in x. So first of all, get change in y, and change in y is y1 minus y0. So we subtract y0 from this equation to get the change in y. And what is y0? 2x0 squared plus 1. So change in y is equal to 2x0 squared plus 4x0 change in x plus 2 into change in x squared plus 1 minus 2x0 squared minus 1. So this will eliminate this, whereas this will eliminate this. And we are left with change in y equal to 4x0 change in x plus 2 change in x squared. Now, we need to divide by change in x to get the slope. So change in y over change in x is equal to 4x0 plus 2 change in x. Now, as change in x tends to 0, what do we do? From limits, we know that we just put 0 in the place of change in x in this equation. We'll be having 4x0 plus 2 into 0, and that gives us 4x, which implies that dy dx is equal to 4x. This is the function for the slope of the curve at any point, which is also called the derivative. So how do we apply this? We pick the first point, that is 0.5. Multiply 4 by 0.5. You'll be having 2. And remember, we got 2.2. That means we're almost close to the answer. So due to some approximation errors, we're not able to arrive at 2, but we had 2.2. Then for the second one, you put 4 times minus 0.25 and you'll be having minus 1. Remember, we had minus 1.2. So which means that we're almost close to the answer also. And the error should also be because of approximation and all of that. So if you're asked to calculate the gradient of a curve at a point, you simply use the derivative, then substitute for x in that function using the given point, and you will get the gradient of the curve at that point. So assuming we're interested in, let's say 0.75, that's the point 0.75, what we'll simply do is to say 4 times 0.75, and that gives us the slope at that particular point on the curve. So that brings us to the end of this lesson. In my next video, I'll be talking about the derivatives of different kinds of function. So we'll be deriving the derivatives for different kinds of function. So please check my next video if you really want to know how to get the derivatives of different kinds of function. If you enjoyed this lesson, I would like to hear your comments. Please do well to like, share, and subscribe. Please subscribe. Your subscription is very, very important to me. Thank you so much.